Alright, hello everyone, my name is Roberto Gulatosti. I'm actually studying for a medical doctor, and I wanted to do an overview of the AI with the healthcare. Basically, I'm an actual healthcare clinic provider, and one of the things that I want to focus is the automatations in order to have better results when it comes to diagnostics and personalized care to my patients. Basically, well, we already know since we have in this class what is AI, but I wanted to do our um, a resume. I wanted to summarize it when it comes to healthcare because I want to explain that AI plus healthcare can be a result or can result in better predictions. It can also support clinical decision making, and for that we have to create a software, or there should be a software in order to fulfill the needs, and basically become this AI a doctor or an extension of it, at least. We have to train it. We have to give this doctor, AI doctor, like the specific things that it have to learn, to achieve, to look for it, and well, that's basically the mix. Um, this AI have to deal with massive data volumes. You can imagine if it connects to a cloud by somehow doesn't have to do anything with IPA or anything like that, but this cloud has this big information about all of the patient, maybe let's say in the United States, then it can compare in real time what if what type of therapy, medicine, um, way of doing things can work, so it could be a big thing in a near future. Obviously, time, uh, when you go to specialized cardiology, endocrinology, they don't have time to treat all of the patient. But if this can be resumed, and all the information that the doctor has to face in order to analyze how can be like taken in a near edge, well, then you can enhance the time of the doctor office time. The other thing is the early detection, where obviously when it comes to doing these treatments, you have to detect it. And if you detect it on an early stage, such as cancer, by example, there is one. Well, here, by the way, the cancer guard. And this is not a hat or something, but this is something new that has to do with analytics and stuff like that. And this is going to do with early detection by blood tests that they put into a system and they analyze it. So, and how they analyze it? Well, they analyze it by pattern recognition, based on real data, based on human observation, and well, basically that it. So well, a three step is gonna be data collection, then AI analysis, and then the medical insight. Basically, that's how the workflows do. Well, the predictive health system with an AI solution, I wanted to provide an info, the comprehensive data analysis. Um, this is all the lab processes matching with the vital sign, medical history, and the genetic information in real time. Then the risk prediction engine that has to be more with the algorithm that calculates the disease probability based on the patient patterns on this database that I've mentioned before. And then the clinical assistant. You have to let them know the doctor that is the caregiver of this patient, this is something bad. There is something bad with this patient based on these biomarkers that give some alert, and then the doctor intervene and decide what have to do with the different alerts that the patient has. And then the preventive care supports. Well, it recommends personalized intervention before symptoms appear. That's once again what I wanted to mention. This example that we have here. This example, it detects and then recommends personalized intervention before the symptom appears, and we're talking about cancer here. So such a cool thing when it comes to cancer. No, it's a difficult thing, but at least we are getting close to it on the early detection with the biomarkers. Well, the core technologies power the system. Well, as you can know, maybe if you don't know, but most of the healthcare clinics provide to the doctors with a EHR system integration that have this electronic collection with the electronic records, and you can seek for all this information that is going to be stored in the cloud. Then you can machine learning algorithms. If you connect this by somehow maybe an API or something to this algorithm that can predict, you can see when you open the clinical chart, you can see, hey, this one by somehow is similar to this case, so have an eye on this. And then the wearable data device. I as well do that device. This is one of it. This is for Whoop company, and basically this is the top tier of the products. And what it does basically, it provide you with this information, how you sleep. If you put here in the recovery, you can see all of the biomarkers, respiratory rate, HRV. If you have the HRV low, you can be getting a fever, you can be getting something related to it, you can be getting a flu, or maybe you are just exhausted for yesterday's activity. But this is something cool because you can in real time be you can in real time see how you're doing. You can also upload your recent lab works to it, and then it will compare and say, hey, you are good, or maybe you have to eat more of this or eat more that, and then this is already getting something with the AI, and it gives you some insights about how you're doing on the day or on the week based on my stress trends. It's a fun wearable to have. You see, it's giving me an analysis on stuff. So well, I actually using it, this power diagnosis, to get early diagnosis if I'm getting tired, if I'm getting maybe getting a fever, as I mentioned before. Then I can get this. I have actually, when I saw my cardiologist, have this thing download my monthly data about the EHR, and then I share it to the doctor, and the doctor analyzes it. That's something pretty cool. Then the cost reduction, because if you are pairing these things with AI, you can you can reduce have an actual reduction of different things when it comes to the preventing area, and the improved outcomes. Obviously, with all of this, there is nothing less to expect than improved outcomes. And then the preventing focus, because you are always continuously monitoring the patient data. Well, one of the limitations, as I mentioned before, is the HIPAA regulations. In the United States, we have privacy, at least I think. But when it comes to HIPAA regulations, this type of regulations doesn't allow this cloud, this data, this big storage cloud to analyze other cases. So one of the main concerns is that the algorithm bias. Yeah, obviously, if you want to train a software, you have to do or give him some bias information, or certain demographic. Where are you going to get that? That's one of the concerns. If you are treating a local, okay, you can go into your local, but you are not comparing a big population. You are just comparing if you have a healthy clinic, maybe I don't know, 5,000 patients. Okay, that's your data. You have nothing more than that. And then the data quality requirements. Poor data leads to an unreliable AI recommendation. You have to have a lot of cases in order to compare and do an average. This is how our average for better results. And then, obviously, the human oversight remains as essential. AI cannot replace doctors because something is AI can give you powerful tools to support clinical decisions, but human judgment is always something that we are gonna seek as humans: judgment, empathy, experience, and then the collaborative approach. Well, AI basically is a tool that have analytical capacities that can give the doctor and provide it with better clinical expertise, creating a partnership that maximize these patient outcomes when it comes to to treatments, when it comes to saving a life. Well, AI will not replace doctors, but will transform the healthcare. Basically, that's it. And thank you for listening. I wanted to do this in person, but there is this way to do it, so everyone outside of class can see it.